Welcome back to this series of lectures on understanding carbon footprints. This is more specific lecture in the sense that we would be learning how to estimate the carbon footprint. The objective of this lecture is to estimate the greenhouse gas emissions, especially the carbon dioxide emissions. In this lecture, we would be understanding how to estimate the carbon footprint for a family, and then also how do we contribute to the environment by reducing this carbon footprint. So this is the plan of the lecture. How do one calculate the carbon footprint of a family? So we need to understand the energy usage of the family in order to calculate, in order to compute the carbon footprint of a family. A family would consume grid electricity for lighting, for refrigeration, for air conditioning, for running the televisions, computers, etc. Majority of this electricity would come from conventional power plants. It could be from a coal-based power plant, for example. A family would consume liquefied petroleum gas, which is also a fossil fuel. More appropriately, it is propane and butane mixture. So LPG is commonly used in most of the households. A family uses transport to travel to work or for partying, for leisure, and most of this transport is either diesel driven or in some cases petrol or gas driven, right? Also, there is a trend of now electric cars coming, and we'll discuss that too. A family might take to air travel for work or leisure. That needs to be calculated when we talk about the carbon footprint of a family. And obviously the consumption goods, which one takes, that is to be considered in the calculations of carbon footprint. Normally, it is agreed upon that we need to separate out two spheres. One is the household sphere and other is the sphere of or the place of work. Okay, so we would be concentrating only on the three aspects. One is the cooking aspect, the grid electricity, which is used for household consumption, and the transport, which the family takes. So these three major sources of energy consumption and their contribution to carbon footprint is what we are going to focus on. So how do we calculate the carbon footprint for that? Let us see the calculations in a bit detail. So for a representative case, we would be considering a family of five people. And let us say that this family consumes about 1 LPG cylinder per month. So it comes to about 12 LPG cylinders annually. Let us say that this family consumes grid electricity and it does not have an off-grid connection. And that grid electricity comes majorly from a coal-based power plant. And let us say that that consumption is typically 300 units of electricity per month. Okay, so again for annual consumption, we need to multiply it with 12. The family has a car, a diesel car, and let us say that the family travels and consumes about 50 liters of diesel every month. Okay, so with this assumption, with this data, we would now be calculating the carbon footprint for a family, right? Now, how do we do that? So for that, we need to know one important parameter, which is called as the emission factor. So we need to know the emission factor for LPG. We need to know the emission factor for grid electricity. And we need to know the emission factor for diesel, the fossil fuel, which is responsible for diesel car. So we have assumed certain emission factors, and how those emission factors are arrived at, that we would be discussing later in the later video. But for the present purposes, look at the assumptions which we have made. We have assumed the emission factor as 2.95 per kg of LPG, 2.95 kgs of carbon dioxide per kg of LPG. We have assumed an emission factor of 0.82 kgs of CO2, carbon dioxide, per unit per kWh of electricity. And we have assumed an emission factor of 2.63 kgs per liter of diesel. So with these assumptions, we would now see the calculations for annual carbon footprint. So the annual carbon footprint for LPG cooking would be the weight of the LPG cylinder. So in this area, it is typically 14.2 kgs of LPG gas is filled in one cylinder. Depending upon the availability of the gas in the cylinder, this value might change. But the family which I had assumed consumes a cylinder which has 14.2 kgs of gas. So the total consumption would be 14.2 kgs into 12. So many kgs, 14.2 into 12 kgs is the total LPG consumption per year. Into the emission factor, which is 2.95, would give us the annual carbon footprint expressed in kgs. I would be converting this annual carbon footprint in tons, and for that, this entire numerator is divided by 1000. So if you do this, if you solve this 2.95 into 14.2 into 12 and divide this product by 1000, you would get approximately 0.5 tons of carbon dioxide as a carbon footprint generated from cooking for this family. For the calculations of electricity contribution to carbon footprint, we should take the monthly consumption, which is 300 units, convert it into annual consumption by multiplying it with 12. So 300 into 12 is the annual consumption of electricity. Multiply it with the emission factor, which is 0.82. And this numerator, when I want to convert it into tons, I divide it by 1000. So again, solving this, we get the carbon footprint from electricity consumption, annual electricity consumption, as about 2.95 tons. Now it would be clear how to calculate the annual carbon footprint for road transport using the diesel car. So as given, as assumed that about 50 liters is the consumption per month. So the total diesel consumption comes to 50 into 12. And that multiplied by the emission factor would be the emissions, the carbon dioxide emissions annually. Divided by 1000, you get it in tons. So if you add this total carbon footprint, annual total carbon footprint, because of cooking from the domestic electricity consumption and because of the local transport by the family, we would get that this family which is being considered, generates a carbon footprint of about 5 tons of CO2, 5 tons of CO2 per family. Okay. Now, this is about the calculation. Suppose this family wants to contribute positively to the environment. So what can it do? So it should reduce its carbon footprint. Now, how much can this be reduced to? So we would do a sample, again, a thoughts kind of exercise. Let us say that this family reduces the car travel by employing certain options like, let us say that by using car pooling or by switching to some local transport. If the public transport facilities are good in that city, they might travel less by car and more by public transport. And this way, they can reduce the car travel. They can reduce the LPG consumption by switching over to a biogas plant. So partially, not completely, but they might use the vegetable waste, which the food waste, which are being generated in the kitchen, and they can purchase a portable biogas plant and switch off certain needs of their LPG on the biogas plant. Obviously, biogas would be a renewable kind of thing. So it would be a carbon neutral kind of option. Same can be done about electricity consumption. Suppose they are using electric heaters, they might switch to solar water heaters. If they are using air conditioners, they might shift to more energy efficient air conditioners, or they might simply reduce their AC use. The lightings they can replace with the more energy efficient lighting. Okay. Now, if they employ such kind of options, energy conservation options, okay, then whether the carbon footprint would change and how much it would change, okay, that would be an interesting calculation. So the next attempt is to explain this. Let us now assume that this family, because of carpooling, manages to reduce their consumption, monthly consumption, by 10 liters. By the interventions which was explained to you, let us say energy efficiency interventions, we would say, club them all together as energy efficiency interventions. Let us say that this family is now able to reduce its electricity consumption by 50 units per month. And by switching over to biogas partially, let us say that they are reducing their LPG consumption by 2 kgs per month. So using the same method, same calculations, now we can show that what has happened to the annual carbon footprint of that family. So now look at this. The annual carbon footprint for LPG cooking now reduces to 0.43. And why is that reduced? That is because this LPG consumption, earlier it was 14.2, now it is reduced to 12.2. So that has reduced the carbon footprint from cooking. Earlier, the electricity consumption was 300 units, now it is 250. So using the same calculations, the carbon footprint generated from electricity has reduced to 2.46 tons. Same applies to the transport by diesel car. The family has managed to bring down the consumption of diesel to 40, and that significantly reduces the carbon footprint from travel. So if you total them now, you see that earlier this carbon footprint from this family was about 5 tons. Now it has come down to about 4. This is an interesting reduction. Okay. So what we could say is that this family has now contributed positively in reducing the carbon footprint. It has managed to reduce the carbon footprint by about 20% by simple interventions. This way, if you look at it, we can understand that a very powerful tool is now in our hand to estimate the carbon footprint for a family, and we can go on a preaching mode. We can do these calculations for the families around us in the neighborhood and tell them, show them their carbon footprint and suggest them the ways of contributing to this environment of reducing the carbon footprint. I hope you have enjoyed this lecture. Thank you very much.